Hello, my name is Gustavo and I'm trying to record a video for Open Source Lisbon. My name is Gustavo and I'm trying to record a video for Open Source Lisbon. And I'm trying to record a video for Open Source Lisbon. I'm here to tell you about Operations Burnout. Specifically, how to say goodbye to Operations Burnout. I am the person above the arrow. My name is Gustavo and I have several skills. One of them is probably not recording videos of myself. So I will thank you in advance for your patience and for staying here with me. I'm representing an international company based in Lisbon called SolidAngle, which you can check on our website www.solidangle.eu. It's 2020. It's a great year to discuss DevOps. It's a year where, for the worst reasons, everyone seems to be able to read a plot. I could not say the same in 2019, but unfortunately in 2020 we see plots just about every day. So everyone now is able to read a plot, even project managers and the marketing teams. And that is great, because there is a plot that summarizes the whole DevOps concept. If we could compare how the effort in traditional IT grows as a function of the project size with the same thing for a DevOps-based operation, we would probably reach a plot such as the one you have in front of you right now. So in the blue line we have traditional IT, which is represented by a linear function. We are saying that the growth is linear as a function of the project size, and we're being generous because we know that the more people, the greatest the crowd you have to manage in IT teams, the less efficient they become. So saying that it grows linearly with the project size is already kind of a forgiving statement. We are at the same time suggesting that the growth of a project size, of the amount of effort as a function of the project size for a DevOps-based project would be something like logarithm. And you could see in the red line a growth which is very fast in the beginning, because you need to invest a lot in getting things done right, and then slows down to a point where it is all the time as the project grows underneath the blue line by a margin, which also grows as the project grows. So this is the central concept. This is the central message that I wanted to tell you about. Everything else that comes later is to be added on top of this. But before that, there's a checkbox to be ticked. I've been told that this is a business-oriented event, and therefore it's mandatory to have a quadrant diagram on every presentation, because it makes it look strategic. And in order to be allowed into this event, I had to find one. This year's quadrant diagram, this year's mandatory quadrant diagram, connects to two dimensions, from dull to cool, from free to fairly paid, in relation to work. As we know, it's very easy to find super cool work for free in our sector. So we just go to GitHub and we find the most amazing projects managed by outstanding teams from brilliant people around the world, and we can just work on it for free, which is nice for a small subset of our time. On the other side of the quadrant, it's obvious, I think, to everyone that it's very easy in IT to find fairly paid or nicely paid but dull work. So nobody's going to name names, but I think the audience is probably familiar with that option, which exists in the market. What I mean to say is that we aim for providing an opportunity for cool work to be developed in a way that it can be fairly paid. It's our goal. Our goal is to go up in the fairly paid dimension and in the cool dimension at the same time, allowing our teams to enjoy themselves while they provide amazing work for customers that understand. The second topic, or the continuing the DevOps topic, better said, is related to how to fail. We are focusing specifically in DevOps, but it's general. The problem of success versus failure is not symmetric. So to begin with, we know that there are many more ways to fail than the ways that there are to succeed. This is probably connected to entropy and to macroscopic laws of thermodynamics applied to businesses. We can think about these in different ways, but the fact is there is a narrow window for success and there is a wide field for failure. I want to address two specific types of failure. The first one is the best one, which is the early crash. When we take off, we are heading to a portal that will take us to another dimension, or at least to a much better place than the place where we are. This is always the idea, but then we crash early. And that's not bad, because when we crash early, we also can quickly learn lessons from the crash. Why did we crash? Maybe because we had the wrong technology, it still happens, or we had the wrong architecture, or we had the wrong team, or we have a mix of all these things. This is okay. It's okay because we can learn. Now the topic that I will address next is a bit more subtle. It might seem obvious to everyone, but it's very rare that people approach it directly. So, how to fail in a different way? We take off, we are heading to this magic portal that leads to a much better place, but there's a surprise in our way. But what is this? It's a planet. Are we going to crash? No, we aren't. This planet has gravity, but we are approaching with tangential speed. So what could happen? We could get in orbit of a planet good enough. Once we get in this orbit of a planet good enough, things will never be great. Things will never be great. Things will never be great. This is something that happens very, very often, and we must not accept this orbit. But this planet is a huge attractor, because there is something called short term that tries to force us to accept things that will get us stuck in the long run. For example, lack of automation. We start setting up a project, but we have deadlines, and therefore we don't invest enough time in automating things. What happens next? We already know. We're going to repeat complicated procedures over and over and over. Crazy deadlines. We accept them because we are told that those deadlines are a must, and therefore we don't do things right. And therefore we have to cut corners. What happens is that those errors which are temporary tend to become part of the way of working. That means we accumulate technical debt. And because the deadlines do not stop, and because we haven't invested in automation, the amount of effort that we need to put in delivering according to the deadlines without the proper automation that we need are not only technical debt themselves, but they are making for more technical debt to be accumulated. And what happens is then we don't have time to invest, for example, in security. Security is a process. There's no magic bullet for security. Security is multi-factor. Security is about minimizing probabilities. Security is many things at once, but we don't have time to be proactive. And many other things. So, if we start from the beginning relaxing on these things, we are officially in orbit of planet good enough. And this is very, very hard to escape. So, probably we are going to be here forever. When someone tells you, but let's accept this temporarily and we fix it later, what I want you is imagine planet good enough. this beautiful orbit, which will get you stuck forever. There are many different companies, institutions, teams, and we tend to think that each case is one case, each case is special, the teams are different, the people are different, and we cannot generalize. But the truth is, we can generalize. From all the diversity of the interactions between people that happens at a microscopic level inside the teams, emerges a set of patterns which are microscopical and which are to be seen almost everywhere. They are very common. So we have seen very often manual deploys, complicated manual deploys, which are multi-step and error prone and often cause problems, which means that people avoid them, which means that every time you ask for a deploy, they will say it's a lot of effort, which means that you cannot fix things fast and bugs stay there for a long time. Manual system configurations are a big problem because everything sophisticated implies changing multiple settings, and if you have to do it manually over and over and over, there will be no two times where things are exactly the same, because a manual process is error prone. These things are not meant to be done by humans, they are meant to be automated by humans and executed by machines. There's the classic problem of lack of centralized credentials across a heterogeneous set of systems. What happens then is that we have stale credentials who knows where, and we have no procedure for keeping the set of active credentials in line with the people that are working in the teams, and this is a huge security problem. Often we see insufficient monitoring, which means that anytime there is a performance or an availability problem, there will be an ad hoc diagnosis, and an ad hoc diagnosis is neither fast nor precise, and probably will not allow us to fix the problem quickly. So if people do not invest in detailed monitor from the beginning, then when the problem comes, it will be very complicated. And then there's clicks. Clicks are an artifact from the 90s. I mean, clicks are great for us to use our desktops on a daily basis. Clicks are not great for configuring critical systems on the cloud. If you have a procedure that is based on 20 clicks, you will get it wrong a couple of times. Your team will get it wrong a couple of times. And the larger your team, the larger the amount of times they will get it wrong and waste time because of it. Nobody wants clicks anymore, because this is not the 90s. The way to go for responsible managing of infrastructures is obviously configuration management with declared configuration management and source controlled configuration code. Then there's the topic of security updates, which are often uncontrolled. You don't know how many are available, you don't know from those which ones should be applied, which ones have high severity, which ones do not. There's no process on how to test them before in a staging environment, before putting them in production, and this in itself is an entire can of worms. And then there's configuration drift related to lack of automation and controlled security updates, click-based procedures. What happens is that you cannot actually replicate systems. It will not be easy to replicate environments. Every time you ask for a new environment, they will say, no, that's a lot of effort. We cannot do it because it takes 3 days. And that's not good, because then there's the temptation of reusing certain environments to test certain things. And that's definitely not good. These situations are part of a pattern. And exactly this pattern that will take us to planet good enough, from which orbit we want to escape. Obviously the question is how to fix it. If there was a magic bullet, I would gladly share it with you, but this is not the case. You can fix it with great tools and a great team. I believe our team is great, and I will now share with you the tools that we are using to fix this problem and never get stuck in planet good enough. So as for DevOps tools, there are 4 central tools that we use. Like, we use this fanatically on a daily basis. We use Puppet for configuration of Linux instances, either in the cloud or in data centers, in our dedicated hardware, etc. We use Terraform to manage cloud resources in a programmatic source-controlled way, rather than clicks. We use Ubuntu fanatically for everything, for cloud instances, for data center instances, for direct installation on hardware, even for our desktops, even the desktop where I'm recording this talk, even routers. We use Ubuntu everywhere. It's been our go-to operating system in the last couple of years, and we use very often Python to do integrations of systems. Different kinds of integrations, from data processing to interconnection. Python is the preferred language for anything that is more than 20 to 15 lines of shell script. So we use it very often. In terms of technology, we are now using the new LXD technology, which is developed by, well, partially developed by Canonical. It's a very interesting technology that allows for containers and virtual machines to be used inside the same environment. And we use also the classic cloud offers like DigitalOcean and Amazon that everybody knows, of course. Part of our daily life is monitoring, and I mentioned monitoring in detail. Here are 2 examples of 2 different things which are correlated, which are monitored independently. So in the plot above, you can see the number of TCP established connections on a specific server machine, and on the plot below, you can see the outgoing bandwidth on the same machine, which, as you can see, shows a high degree of correlation with the number of established connections, but it's not a perfect correlation, so we monitor it individually. Other interesting things to be monitored are, for example, the response times of systems. You have here an example of an HTTP server that behaves very well for most of the time, but a couple of times per day, 6-7 times per day, the replies take more than 6-7 seconds, which is not good. And we are able to realize that because we have this very detailed monitoring checking the system during the day. So without this, we would not be able to persuade whoever is responsible for this problem to take action to solve it. But this evidence allows us to request some action for whoever is responsible for the situation, therefore allows us to serve our customers much better. Still on the monitoring topic, I would like to share 2 monitoring probes that have been developed internally. One is the probe that allows for detection of the state of synchronization between a Linux instance and the centrally managed configuration that is mandated in the Puppet master. So it's as usual a green light, red light system. If the Puppet configuration is not synchronized, if the agent has a problem running, or even if there is a configuration error on the declaration of the configuration of that machine, we will see a red light and there will be an alert, and our team will be told to fix it, obviously. Without this, we would declare a configuration, but we would not be sure whether the configuration has been properly applied. Or we would have to SSH to hundreds of machines and run the Puppet agent by hand to check the status. But that's not doable, that doesn't scale. So we developed a way to do it automatically. Another automation that we developed for monitoring is a probe to count relevant security updates. And they are relevant. Being relevant is a criteria that can depend on the context, but let's imagine that they are relevant if the severity of the security update is at least medium. I mean, medium or high, for example. We have an automatic probe that lists the number of machines, the number of packages in such conditions on each machine. So compare doing this automatically to SSHing to hundreds of machines and trying to measure this by hand. That obviously does not scale. Or compare it to not knowing anything and not doing anything, or hoping for the best, just applying all the updates everywhere. It's not a good idea either. So this kind of fine-grained monitoring allows us to, not using too much time of our team, be aware and prioritize what needs to be done. So here's an example, only with 3 machines, where we are informed, the alert goes to warning state, and we are informed that there's a number of packages that need to be updated on each machine. Those packages have severity of at least medium, otherwise they would not be counted. But this is of course configurable and depends on the criticality of each machine too. And finally, as a bonus section of this presentation, because I've already given you, I don't know, maybe more information that you can process, as a bonus we have the 20 lines virtualization server. If you want to know more of this, we can please contact us and we will gladly share with you more information. But this example is just how to configure a virtualization and container server in 20 lines of code. So you see, I'm not saying 50 clicks, I'm saying 20 lines of code that we control. I think this is a good example of how to wrap complexity in a declarable, DevOps-friendly language that allows you to replicate as much as you want without increasing the likeliness of error. So with these 20 lines, you can create an LXD virtualization and container server where you can create containers and virtual machines either by clicking or by using the command line, or even by declaring them directly as a Puppet resource, which also works very well. Please contact us if you want to know more about this. Finally, I wanted to give you an example of our customers and also express our gratefulness to these customers, because it's thanks to them that we can go on doing interesting work, having a team that has the privilege to do interesting work. It's a consequence of the support of these customers who have been advanced enough to understand the value of DevOps. So finally, we can say goodbye to Operations Burnout. You can say goodbye to me as well. I'm Gustavo, the guy on top of the arrow. Please contact me if you want to know more about any of the technologies or any of the ideas that I mentioned. And please check our website at solidangle.eu. Contact us if you need something. Thank you very much. Have a great day.